So, good morning, good afternoon, good evening, ladies and gentlemen. Please allow to introduce myself to you. My name is Musbah Muqbil, and I am USG Middle East Regional Marketing Manager. Thank you for your interest to attend our 9th online technical webinar titled Safety in Case of Fire in Buildings, presented by my colleague, Mr. Christophe Blanc. Mr. Christophe Blanc is a Product and System Development Director based in USG Boral JV in Bangkok. Within our today presentation, we will showcase the best practices to learn about risk of fire spread within buildings and architecture solutions to ensure safety of people and goods in case of fire in the buildings. We will discover the solution of their secrets and performances against heat and fire. And we will exchange with the world expert in the building physics field and ask any questions you want on these aspects. Mr. Blanc, our today's speaker, was named Product and Systems Development Director of USG Boral JV in December 2014. In his current role, he leads the Product and Systems Development team, part of the USG Boral R&D Center. Key missions of the team are innovation portfolio and project management, value engineering, support to the business unit, testing and certification as well. Mr. Christophe, he leads the construction of the 2 products and systems testing centers in Thailand and Korea, both opened in 2014 second quarter. He is a member of the Central Innovation Committee, and he drives the network of the innovation champions within the JV. From 2007 to 2011, Christophe worked in Lafarge Gypsum Division at the Technical Development Center in France. He was the head of fire laboratory, and he was appointed project leader of several group initiatives around fire protection, glass mat board, as well as insulation. He joined Boral Gypsum in Asia back to January 2012 as a Product and Systems Development Manager. Christophe holds a Master Science in Material Science and Engineering and an Executive Master in Strategy and Management of International Business from SA Business School in Paris and Singapore. For our business unit of USG Middle East, we play our major role in the MENA region to meet and present the latest in the building materials industry, and thus invited for continuous technical summits which we are conducting on a monthly basis, where we have considered the last few days of each month, 3 p.m. KSA time, which is GMT +3. At USG Middle East, we work very close with our partners, project stakeholders, and other businesses to share the best practices and find new ways to advance performance. Even we work more closer with the regulators and construction influencers to meet the latest construction regulations and building for materials supply compliance. And this to confirm our mission to deliver innovations that helps you to work smarter, do more, and build better. For the attendees who are attending this webinar for the first time, just a quick brief about Middle East operation in a glance. USG Middle East has a multiple manufacturing facilities based in Dammam, Saudi Arabia, Doha, Qatar, and Turkey that allow us to supply any project in a speed and high technical support. And the company has more than 334 UL certified ceiling systems and drywall assemblies, which are as a result for education and excellence and innovation. This specialized introduction for safety in case of fire in building session will be recorded, and we'll share it with all of the participants after the meeting is ended. And please know that each participant will receive a 1-hour credit of continuous development CPD certificate after this webinar. Please send your questions to the chat box at any time, and we will share the answer for your questions at the end of this technical event. Before we start this and I leave the podium for my colleague, Mr. I would like to present the gratitude for our colleague, Mr. Muhammad Ismail, whom leading of all of USG Middle East webinars, technical arrangements, webinar setup, invitations, and media management. His efforts were translated into the continuous successes for these technical webinars, 9 so far. And now let me please leave you with the presenter, Mr. Christoph, for his technical webinar.
Thank you, Musba, for this kind introduction. I wish to tell good morning, good afternoon, and maybe good evening for some of the attendees. I'm truly pleased and honored to get the opportunity to share with you today about the safety in buildings in case of fire, and having the possibility of interacting with you by answering to your question at the end of this presentation. Let me start sharing my screen. Share. Please. Musba, can you confirm you can see my screen?
Yes, we can see the screen.
Okay.
But if you can go to the first slide, please, Christoph.
Yeah. Okay. And I will.
Yes.
Move this.
Christoph, if I may allow, just if you can raise your voice a little bit, please.
Yes, sure.
Yes.
Is it? Yeah. Let me know if it's not loud enough.
It's loud. It's good now. Thank you.
Hear me well. Okay. So safety in case of fire in buildings and talks about fire boards and system is the topics of the CPD training today, with various objectives, at least on the first part of these sessions. I'm willing us to understand the mechanism of development of fire, discover the fire-resistant test methods that are used to assess the fire rating of any construction systems, see how fire systems and boards, I'm speaking here specifically of gypsum board-based systems and boards, behave when exposed to heat, understand a little bit the formulation of fire board, fire gypsum board, that ensure the fire resistance of the systems in which they are used for, and be aware and mindful about quality and characteristics of the fireboards within USG board. There is a specificity of fire-rated system and fire-rated performance of plasterboards. Ideally, we wish for our customer and for the project that the performance would ideally never be needed. I mean here, the fire safety and the passive fire safety offered by our systems is required in events of disaster or fully developed fire within the buildings, which obviously is primarily to be avoided. But in a case of such occurrence, the fireboards and systems of USG Board are here to save lives and to save properties. We sometimes thinking that fires in buildings are scattered events, but it happens periodically, a little bit everywhere in the world. And you might have seen and heard that 1 or 2 days ago, there was a big facade and building fires in Milano. So in any regions of the world, including the regulated one, there is sadly events that recall us that fire is not just pure imaginations. There are periodic fatalities leading to loss of buildings, loss of exploitations. Buzbek, can you still hear me?
Yes.
Yeah, okay, because I had a signal that I was muted, showing that those are not scattered events, and this happens. I'm showcasing here, if I may use the term showcase, some events that occurs in Asia for this example of this. But any of the countries had sadly, opportunity to demonstrate such fatal events, and in some cases bringing to loss of life. So as an introduction to the dynamic of fire and how does a fire start spread till becoming a fully developed fire, I will soon show you a brief video to introduce about the stages of fire development. But how does it start? So it needs 3 components, as you may know, like something to burn, a combustible product, some energy, and a comburant, which is oxygen. It's usually starting with furniture, mattress, foam, or any combustible product that is initiated the fire that at first, in the first second, in the first minute, can be mastered or extinguished, if I may say. But there is also some design and ventilation conditions which can lead this fire to spread in the room, and in some extreme cases spread out of the room. With regard to this mechanism and steps, I'd like to get back on this. So in terms of stages of fire development, there is one, ignitions, which at this stage can be mastered through extinguisher if there is opportunity to have a quick reaction of this. Then, depending on the ventilation conditions, presence of more or less combustible products or furniture in the rooms, there is a fire growth, which in extreme cases can lead to what is named flashover, or fully developed fires within the rooms, which flames can get out from the original room to spread to another room, adjacent corridors, or in some cases, adjacent floors. Let me guide you through a video that will allow you to visualize this stage of fire. Just willing, before this video, to tell that between the stage of ignition, so start of flames in a small scale, till the occurrence of a flashover, this time can be extremely small. When I say small, like within 3 to 5 minutes, if the condition within the room is combining combustible products through furniture, ventilations, the states of starting from ignition to a fire that cannot be mastered anymore can be very quick. On the first stage of the fire, we are dealing with combustibility or non-combustibility of fire that is treated under reaction to fire. The scope here is to avoid or to delay the flammability and ignition of within the room. After the flashover, that goes with a quick increase of temperature and influx and heat flux into the rooms. The scope is to prevent or at least delay the spread of this fully developed fire to adjacent room or adjacent floors. This is the field of fire resistance what we are dealing with. The videos is going to show you two things: the mechanism of fire from fire starting in an armchair till flashover, and we'll show you and demonstrate fire resistant tests that we are periodically running on our gypsum based system. So let me change the screen and I'll start this video, which I will comment. So we are here at the ignition stage. This can be a cigarette or candles in an armchair in these conditions with a relatively limited fire. And the more it goes, the more there is smoke development and fire spread. Either this is to the adjacent walls or curtains, chairs, or carpets. You see here at this stage that there is a continuous temperature increase and hot layers of gases, which can lead up to a flashover. This was quite quick, and this was not a real-time videos, but in the real case experimental test that was conducted in laboratory conditions, the time between the start of the fire in the armchair to the flashover was within 5 minutes of times. So you have seen the flammability that is driven by the reaction to fire of the armchair. This is easily and quickly flammable, rising the heat release within the room and elevating the temperature quite much. Sorry. We are going now to visualize a fire resistance test on the gypsum board partitions, which is including a windows here, the glass windows, a fire retardant glass window, and fire doors, just to start to drive through and introduce the next session, the next part of the fire resistance test. So this is here the non-exposed phase. Can start. Okay. And you can see the burners in the fire that is following a relatively quick temperature increase, just to simulate and to model what is occurring in the case of a fully developed fire in a building. You see here the glass windows has turned opaque. It's a fire resistance window. This is a view of what is happening in the furnace here. So there is a burners that are used to follow standardized temperature time curve. You see that the resistance doors that is wood base is flaming and bringing some heavy temperature. This is here the non-exposed phase. So you see here that the windows here has collapsed. So there is an obvious loss of integrities with a sudden big holes in this case of flames, which would stop the fire rating in the case of laboratory. So like visual introduction, if I may say, on the 3 stage of fire: ignition, sprayed, up to flashover and fully developed fire conditions, which is calling for fire resistance systems that are necessary to contain, delay, and ideally prevent the spread of this fully developed fire to adjacent room. Let me guide you now through a little bit of more details about the fire resistance test and the way that they are performed on our gypsum board systems, or by the way they are applied on any kind of construction systems. I spoke of a temperature time curves. There is like a worldwide or international standardized curve that you can visualize here. That is, if I may say, mimicking the elevation of temperature and heat flux that is occurring in the true life, if I may say, in case of a flashover. You've seen the flashover, these sudden times where the fire in the full room is getting covered with flame. At the beginning of every fire resistance test, the speed of temperature increases is very high. We are reaching around 500 degrees within 5 minutes. We are at more than 800 degrees after 1 hour, close to be at 1000 degrees at 1 hour 30, and slightly above 1000 degrees after 2 hours. So this curve is the one that is applied and followed by any fire resistance furnace in the world, used to qualify and assess and rate the fire rating performance of construction system. Let me guide you through a picture, through the mechanism of development of fire and what is happening on the gypsum board partitions. That is here having 2 double layer 12.5 millimeter boards. This could be 2 layers of half-inch or 2 layers 13.0. This is a typical gypsum board partitions design that achieve 2-hour fire rating. So after 5 minutes, and recalling what I've just said about the level of temperature, at 5 minutes, the temperature in the furnace is above 500 degrees. So what is relatively quickly happening is that there's a charring and disappearance of the paper face of the exposed face. Then during the half an hour and following hours, relatively fusing is happening on the fire board partitions. You can see a little crack or joint opening due to the dehydration process of the gypsum. I will get back to this, but all in all, there is a stability of the system. So we are here at 1 hour. We are above 900 degrees, and the boards on the non-exposed side are still in place. Around 1 hour 15 minutes, 1 hour 15 minutes to 1 hour 30 or more, you can see some partial falls of the first exposed layer of the partitions that remain additive up to 2 hours. And here, this is the end. You can see 2 hours 9 minutes. I can tell you that this is the end of the test and the fire rating due to one criteria, which is the thermal insulation criteria. You might see or not some cables and with thermocouples that are set on the non-exposed phase of the partition. These sensors are used to assess the elevation of temperature on the non-exposed phase of our systems, and this is linked to the criteria of thermal insulations. And the thermal insulation is stated that once the maximum elevation is reaching 180 degrees, this is a rule set in the standards, the test is completed. But one interesting thing to observe on this gypsum board system, and any kind of gypsum board system, you might see that the wall is here, still in place, almost unchanged, apart some browning area at screw heads. So at the end of a 2 hours fire rating at the gypsum partition is still here, holding in place and structurally stable, but just missing this criteria of thermal insulation. So this was like a story of 2 hours fire resistance test in picture. Let's get back to the criteria of fire resistance, which are linked to the dynamic of fire development in the building. So there's 3 main criteria. I should say 2 for non-load-bearing systems, which is usually the case for the gypsum board ceiling and partitions, but 1 is load-bearing capacity. Most of our systems are not load-bearing, although they could be screwed on a structurally load-bearing system. It's here linked to the type, thickness, and sections of stud or steel provided is being used. Another in the integrity is just ensuring that all along the test, there is a tightness against flames and flammable gases. You might remember seeing in the videos of the fire resistance test, the fall of a window. So there was suddenly a big opening in the walls. That's an obvious loss of integrity. The standard is actually more severe than this. It stated that there should not be cracks that are too large enough to let the flames or hot gases go through the partition. And the last but important one that I spoke and share about already is the thermal insulation, stating that at any point of temperature measurement on the non-exposed phase, the elevation of temperature should exceed 180 degrees in any single point maximum, or an average of 140. I wish to remind here that at 2 hours and above 2 hours of fire rating, the temperature in the furnace and in the condition of a fully developed fires in case of buildings is a little more than 1000 degrees. And the criteria set for the thermal insulation is 180 maximum. It gives you like a feel of the thermal barrier, thermal shield insulation capability of the gypsum boards with more than like 800 or 900 degree difference between a fully developed fires and a protected area. A little bit of, I'd say editorials and vocabulary, if I may say, on the way to report the fire resistance rating. You might have seen, or you might be familiar with FRL for fire resistance level, and with 2 to 3 digits, respectively linked to load bearing capacity, integrity, and insulations. Some are also using REI, so I for insulation, R for resistance, and E for, I don't know, let's say for tightness towards flame and gases. So the way it's reported is that, for instance, a 1 hour partitions could be stated as a 1 hour load bearing partition would be stated as a REI 60 system, 60 here standing minutes of fire rating, or fire resistance level, FRL 60, 60, 60, respectively for load bearing, integrity, and thermal insulation. In the event, and here it's a pure exercise here, of a load bearing system that would achieve more than 2 hours fire rating, but only more than 1 hour integrity and less than 1 hour insulations, the way to write the classification of this system would be, or could be like this: R120 to specify that the structural stability is ensured during 2 hours, but RE 1 hour to state that the combination of load-bearing capacity as integrity is only covered over 1 hour. This is the shortest fire rating times. Or if we want to state the fire ratings combining the 3 criteria, this would be REI 30. The way to write this and the FRL way would be FRL 120, 60, 30. Just a little bit of vocabulary, might be a bit boring, but I think it's good for the audience to be aware, if it's not the case yet, of the different way to assess, write, or report the fire rating performance of system. So we have shared on the way to test a little bit of discovery about gypsum and gypsum boards. So the scientific name, so the molecular names, if I may say, of gypsum is calcium sulfate dihydrate. We'll not go into the details, but for the chemists, materials engineers in the audience, you can see the calcium, you can see the sulfate here, and the dihydrate is linked to the 2 molecules of water that is part of the composition of gypsum. And these 2 molecules of water are part of the secret of the very good and high performance of gypsum boards when exposed to heat. Let me tell you a little bit more. These, the molecular weight of these 2 molecules of water, H2O here, is around 20% of the weight of a board. So these combined water, it's crystalline water, or combined water. Obviously, it's not liquid water within the board, but it's part of the chemical composition of gypsum, is 20% of the dry weight of the boards, and it requires quite a lot of time and energy to break the bonds of this molecule of water. So this is one of the secrets of the passive fire safety procured by the gypsum board. Is this is their intrinsic content of combined water, which, depending on the thickness and depending on the type and density of board, I'm speaking here from 12 millimeter regular standard board up to a thick and dense fire boards, it's anything between 1 liter, the equivalent to 1 liter, or 4 liters of water per square meter of plasterboards. It's quite a lot, and as I said, it requires time and energy to dehydrate this board. This is one of the, this is not the only one, but this is one of the key performance secret of the gypsum boards when exposed to heat. The reason is that you remember these temperature time curves, which is being used for any fire resistant test. When you're looking at the fire resistant test and thinking about the thermocouples that are set on the non-exposed face of the partitions, there is a pretty long, what we call vaporization periods. That is linked just to poor, physics phenomenon. That as long as the gypsum board is containing water and combined water in its core, the unexposed sides of this plasterboard will remain at or around 100 degrees, which is, as you know, the level of temperature of vaporizations of the water. So this is this level of energy and temperature that is being used and necessary to break the bond of these water molecules set in the gypsum. and there is a long vaporization plateau or periods through which there is a limited elevation of temperature on the non-exposed phase of the temperature. What happens after depends on other aspect and recipe of the boards. I mentioned that the facer could be a paper facer. We do have gypsum board which facers are made on non-woven glass mats. This means that it's non-combustible glass mat where the cellulose fiber is replaced by glass fibers. Density is an important criteria. You remember seeing the bottle of water. The fireboards are definitely usually dense boards, and everyone will understand that with density, with weight, it means that through the 20% of combined water in the board, it means more quantity of crystalline water set in the boards and longer vaporization periods when exposed to it. The fireboards are mechanically reinforced with glass fiber. It's in some way composite materials where the glass fiber around half inch, 12, 13 millimeter glass fiber are set and embedded into the core of the gypsum board, increasing the mechanical integrity and the core integrity of the board when it is exposed to extreme heat. And there is some other additive to counterbalance the shrinkage effect. I'm speaking here of shrinkage because you might be thinking that with 20% of combined water, once the board is fully dehydrated, it has lost 20% of its weight, and it goes with some micro cracks, micro or macro cracks, which can be delayed or balanced with anti-shrinkage. So there's, although the boards might look the same, there's a huge difference between a regular board, relatively light, no specific fire additive, and a fireboard, which is much denser and include a mix of fire additive to substantially increase its behavior when exposed to heat. I'm getting back to this curve of temperature temp curves, and this would be what would occur on the non-exposed phase of a wall, let's say. Like quickly after the vaporization period, regular boards will have relatively quick failures, whereas fireboards with addition of glass fiber and anti-shrinkage additive will get through combination of its higher density, higher content of combined water and fire additive will have a much longer integrity when exposed to heat. And in addition to this, I mentioned that the design of systems or the type of facer can lead to a more or less long fire resistant time. I will get into the details of some typical gypsum-based systems to drive you through half an hour, 1 hour, 2 hours. It can go longer than this using gypsum board. Just a few pictures to illustrate what is set within the glass fiber. So either we cut or we set pre-cut glass fibers in the gypsum board, and if you score and snap fireboards, you will see these glass fibers. I was speaking of composite materials, like similar effect of mechanical reinforcement and integrity of glass fiber. Either the glass fiber are set in like resin for composite materials or in gypsum boards, but this is one of the formulation aspect of the USG ball fireboards. Another set of additives to counteract or counterbalance the shrinkage. Typical one is vermiculite. It's small mineral flakes, which when exposed to heat around 300, 400 degrees C are expanding. You see here core vermiculite and vermiculite that has been exposed to heat. So it's filling the gap of the micro cracks, delaying these cracks and delaying the effect of shrinkage. So I was willing to spend a little time to unveil the formulation secret of gypsum boards. Just mentioning that in term, Muzba mentioned the plants and the operation that we had in Middle East, and we do have in almost all across the world. The fire additive and the recipe are qualified and specified by research and development team. The formulation within the plants, this is the role of our plants to ensure the consistency and respect of the recipe, either dry weight, type, and content additive. And those fireboards are heavy on a product, but still more than other, are subjected to continuous quality control. These quality control are about the shrinkage, the core cohesion. You see here a small scale test where a fireboard is subjected to 1000 degree burners both sides to make sure that the core integrity is ensured during 1 hour. And more important, and maybe very also important for the attendees here, the fire systems are tested, so fire resistant tests, which I've briefly described to you. And we do have all a set of third-party full-scale fire tests to assess the fire rating of our system, either be partitions or either be walls, and this is periodically renewed. So through this first session, we discovered about the mechanism and the 3 stages of fire development: ignition, spread, flashover. We discovered the fire resistant test. I'll get back a little bit on this. And we also discovered the recipe of gypsum board. It's time now to share about the building codes and regulations objective. Share with you about the system designs and the fire rating that can be reached with a plasterboard system, and get some good installation practice and typical details. I was willing to spend a bit of time with you because either be to ensure the fire safety. I could make the same remark for acoustical comfort. It's good to get nice and high performing components, good and high performance plasterboard, but it's also quite key to apply good installation practice just to make sure that the passive fire safety of our systems or acoustical performance is sustained. And due to the exposed to it, you will see that there is some key detail that we need to get in mind. So in terms of fire engineering, I went through this already, but you see here a partition at the end of a fire test being exposed to this time turf temperature. This was to introduce in terms of fire design, fire regulations, and the scope and the objective of building codes that are setting the rules in terms of level of fire rating per system, per type of building, are quite simple, but very important. Keep the people safe and provide them enough time to get out of the building in case of a fire, and limit as much as can the risk of fire extension and consequences. So save the people and keep the goods or the buildings as much as can its integrity. So in terms of fire design and fire regulation, thinking of save life and keep the people safe is ensuring that within the building, depending on its type, on its occupancy, of its numbers of floors, in case of a fully developed fires occurring in any of these rooms, people can be warned in advance and can safely escape through practicable safe exit that are linked. Let me show another aspect of fire design and fire safety engineering, just making sure that the room and compartmentations and design per the building code is set such as the room-to-room walls or room-to-corridor walls stated at either half an hour, 1 hour, 2 hours, depending on the occupancy, depending on the purpose of the building or of of the occupancy. For instance, in hotel or in hospital, where people are here to sleep or to get a rest, usually room to room or room to corridor fire safety requirements in building codes are higher than what it could be in other type of building. In terms of fire compartmentation being here to prevent or delay the spread of fire from a room to another room. Other aspect in a building is that to get strategic placement of dangerous equipment. When I say dangerous equipment, having a highly heat rate release or combustibles or flammability, to get this in storage area which are highly protected by 2, 3 to 4 hours walls, and get compartmentations all across the floors and between the floors to leave practicable escape route in case of development of fire. One typical examples in this could be hotels, but this could be hospitals. But I'm claiming this because the set of 1 hour fire rating from room to room, 1 hour fire rating would be a minimum. 2 hours between between room to corridors, or 2 hours for the corridor walls. And in very high or very large building, there are usually an additional level of compartmentation, stating that it can be every 6 room or every 20, every 25 meter. There is additional compartmentation rooms which would allow to contain the spread of a fire. So a typical design of walls per application of a building codes could be this one. You see that the walls in blue would ensure a 1 hour fire rating from room to room. The escape route and the corridors would be 2 hours, just to allow every people set in the room to reach one of the escape route. And in addition, every 5 to 6 room, maybe 20, 25 meter, get an additional compartmentation walls, meaning that this could lead some room to room or room to stairs or room to shaft being fitted with a 2 hour walls instead of 1 hour wall. The logic here is, in case of a fire occurring in one of these rooms and sadly extended to other rooms, there would be extra delay to confine and constrain the fire in this area till the fire brigade can come and be active. Okay, I hope it's clarified a little bit the logic of fire building code and the logic of fire system design within buildings. For very specific building and shaped tower or high-rise buildings, the fire engineers and designers are putting some refuge. So it's empty floors or non-operational floors on daily basis, which offer usually very high resistance times to fire. When say very high, it can be 4 to 6 hours or more, purely bare and thick concrete. In the case of people would be trapped and not being able to reach the ground floor, at least being kept safe long enough and away from a fully developed fire that would or could occur in one of the sections of the buildings. No need to tell you that the Middle East is a great place for high-rise and majestic high-rise building. These refuge area, escape floor, if I may say, are part of the design of the building, despite you might not be able to see them because it's glass with windows, but this is usually part of the design. I'm speaking here of high-rise towers, so 150 meter or more. Fire building codes, we went through a review of all the applicable fire building codes here in Asia. We could have done the same in Middle East, Europe, and the US, but being familiar with the building codes on any of the components, any of the continents, all are taking into account the type of building and type of occupancy, the size, the capacity of persons on the numbers of stairs, and this is what is bringing the various civil defense or fire brigade to set the rules in terms of compartmentations, fire rating of system, either walls or ceiling, thinking about the objective of fire safety in building, save life and leave enough time to people to escape from the buildings, and confine or restrain the development of fully developed fires so that the fire brigade have time to stop the fire before the building is fully destroyed. So we went through this. I was willing quickly to illustrate the reaction to fire, the assessment of the flammability or non-combustibility of product. So we are speaking here of reaction to fire test. This is usually a relatively small scale test to which our gypsum board has submitted, by the way. But despite the presence of either paper facer or non-woven glass mat, all or any gypsum board is falling in the non-combustible families of product. It's purely mineral, and remember as well that the 20% of dry weight of the combined water set in the gypsum boards make that it's impossible to ignite a gypsum board. This is to illustrate, or to refresh about the criteria of fire resistance test. One is structural adequacy, making sure that the system shear wall will stay in place. Integrity, making sure that the tightness toward the hot gases or flames is ensured during the fire rating times, and the thermal insulations, which you remember the criteria, 180 degrees C as a maximum elevation of temperature on the non-exposed face, or 140, whereas in a typical fully developed fires, the rise of temperature can reach 1000 degrees. Fire resistant tests and full-scale tests apply to either vertical or horizontal elements, so walls, partitions, ceilings, or floor ceilings, and there is bespoke fire testing methodology for this. You can see here installation or hand of installation of partitions, which goes here with a cementitious rendering. And by the way, it's a Duroc, it's a cementitious here, a combination of cementitious and fiber rock partition. So it's part of the lightweight construction solutions, but not purely gypsum boards. And on the non-exposed face, as it was illustrated former in my presentations, presenting a fire resistant test, you can see all the cable and these white spots are as many thermocouples that are set on the non-exposed face of the partition to assess the criteria of thermal insulation. It's not easy to read, but you can see 2 hours here. Again, at the end of 2-hour test, the non-exposed face is almost looking like normals, but there has been at least one of the points, or we are close to reach the time where one of the thermocouples will reach a temperature of 180 or more, which will be the end of the fire rating time of this system. So gypsum board and gypsum board systems with regard to fire ratings. I mentioned that we do have some regular boards, which provide by itself some fire resistance level. Single layer 12.5 millimeter regular boards about framing can provide up to 30 minutes. This could typically be office to office fire rating. Double layer 12.5 millimeter regular board, so without any additive and relatively low density, could be used to reach 1 hour. But in fact, these fire rating times can be reached with a single layer 12.5 millimeter fireboards. So you remember fireboards denser with a mix of fire additive. With or without rock wool, we are usually used to usable classifying our system with a free cavity with no wool, which allow to extend the fire rating to system with wool. 2 hours partitions. If you heard me clearly, 2 layers of 12.5 fireboards on the framing are ensuring a 2-hour fire rating. Some of the system to illustrate.
Sophia,
I mentioned the
clear.
Sorry.
Your voice is very clear.
Okay, good.
Just to confirm it.
Okay, no, that's good. 1-hour system, single layer 15 or thicker boards. 2-hour systems, double layer 12.5. So you can see that by adding and increasing the protection thickness on both sides of the partitions, we can reach, I like to say, with regard to the building codes, any regulated fire rating, as it's not that usual, but in some warehouse or critical storage area, as I mentioned, we sometimes have to provide 4 hours rated walls. We do have similar system for exterior wall or glass walls, combining like a regular fireboard with a non-woven glass mat board that is that can be selected for wet area room for Ticebaker. We do have wall linings, so just boards on a single size, where 2 layers of 15.9 FR would ensure a 1-hour fire rating. And we do have a shaft wall, typically for lift shaft or stair shaft, where the combination of a thick shaft board, 25 millimeters set in a specific what we call C-edge stud, and 2 layers of 15 or thicker boards is ensuring 2 hours. I mentioned 2 hours because typically the lift shaft has to be rated 2 hours. Sometimes 1 hour if the building is not too tall, but 2 hours is more common. I've briefly covered here wall systems. Same mechanisms apply for ceilings, where we do have either 1-hour fire rated ceilings or like a double deck, 2 times 2 layers of 15 millimeter for some project which require 2 hours protection. It's usually typically in airport or large project where between the concrete slab and the back of the ceilings, there's a lot of potential combustible products through electrical cable or duct or combustible process that are set into the plenum between the concrete slab and the ceilings with a requirement of 2 hours protections brought by the ceiling itself. So excluding the concrete slab, just to provide heat and fire protections to any combustible cable or other components that could be set in the plenum. One specific segment is structural steel column and beam encasement, where the fire rating here is to ensure the load-bearing capability of steel components. You can see here I or H beam protected by single or double layer of gypsum board. And depending on the section of the steel or size of the beam, the use of gypsum boards can allow to ensure the structural stability from at minimum 30 minutes up to 3 hours in some cases. I will not spend too many times on this, but the fire building codes are linking this structural stability to a critical temperature of usually 500 or 550 degrees C. It depends on the what is named shape factors, let's say size and dimension of linear weight of the beams. And we do have tables which allow from the desired fire rating, it's a matrix here for 2 hours, and the shape factors and size that allow to provide you with protection thickness required using gypsum board to ensure the structural stability of this system. I'd like to spend the rest of this presentation to provide you some installation practice and typical details. You will see here this installation practice in laboratory environment, but this is applied in the true life. So this is important for architects or supervisors, inspectors to get this in mind. I spoke a lot about fire safety. This is the topics of tonight. The prerequisite for any of our system is to get at ambient temperature structurally well designed system, either wall or ceilings, because the stud deformations is increasing the stress on the boards, and it could accelerate the fall of boards. So it's important that the USG board team are here for this, that the fire rating is, prior to the fire rating, is linked to a proper structural design and selection of steel stud for wall or furring channel for ceiling. I was illustrating partition. This is same here for ceilings. The key message, get an adequate structural designs is a prerequisite for fire test. The rule is simple, it's just to make sure that in terms of ambient temperature, we do have mechanical designs in terms of serviceability and deflections that are properly designed before being covered or layered with gypsum board. One aspect here for the system is that when exposed to it, the steel stud during a test, or when exposed to, sadly, to a fully exposed fire in a building, are subjected to high temperature. It can be up to 600, 700 degrees, which goes with steel expansion. So it's important to leave a free gap between the steel stud and the top rack that is used to fit the partition. So the rack are set at all the perimeter of the partitions. Studs are usually set on the bottom track, and it's important to leave what we call a expansion or thermal expansion gap at the top of the stud and the rack, and to avoid any mechanical fixing point, any screw between the top rack and the stud. It has to be free. I can ensure the audience that the mechanical design and structural design is perfectly ensured, but for fire safety aspect and behaviors, as you see, we need to get free thermal expansion in case of fire safety. This applied to wall with a kind of wall of 5 millimeter every 3 meters of systems, or to furring channel in the case of ceiling. If not apply this, if there's no expansion gap, and this was a bespoke test, if you set in contact the studs with the top rack, you increase the risk. You will have occurrence of flanking or twisting of stud, which will lead to premature fall of boards during a fire test. So this could lead, and this would for sure lead to loss of fire rating. And this can be a substantial loss of fire rating. So I was willing to zoom a little bit on this. The screw as well, it's better to get a screw as close as possible to the stud or the furring channel flange rather than the board joint or the board edge. Reason is that the shrinkage of boards is usually linking to airline cracks or crack at the screw heads. And this is where there's a loss of mechanical fixings that is the start of potential fall of board. So it's better to get the screw as far as possible to the edge, typically and ideally 10, ideally even better 15 millimeter from the board edge than too narrow about this. This is typical installation details which our installers or contractors are trained and familiar with. In case of multi-layer system, making sure that the boards of inner layer and outer layer, the edges of boards of inner and outer layer are staggered, just to avoid a straight line or risk of thermal transfer from edge to edge. It's also part of usual gypsum board installation rules. I mentioned that most of our fire resistance tests was made with our own mineral wool. The mineral wool is usually helping or bringing benefits to the fire system. So this is the reason the USG board is usually driving tests with free cavity, and this can be extended to similar tests with wool. The wool being here primarily usually for acoustics and possibly also for fire. Between the two big families of mineral wool, glass wool and stone or rock wool, the rock wool is the one providing benefits to our fire systems because its melting point is very high. It's basalt made, so it's about the melting point of steel. So it will stay here. But for the audience here, the things to remind is that one fire test proceeding on a free cavity system can be extended to similar system with mineral wool. Close to the end, there is typical questions that about is a fire resistant test, is this representative of the reality? Do we have example? So first is that, as I mentioned, all the fire resistant tests are standardized and performed following similar rules worldwide. All the building codes for the fire rating of resistance refer to this type of test. Either this is a Astm, like US-based, BS, British Standard, ISO, or some other, all are referring to the similar temperature time curves and follow the same rules of fire rating. There is few, but there are examples of real scale fire tests, and USG board got the opportunity to be involved into one. It was more than a full or large scale. It was a real scale warehouse filled with more than 300 tons of wood, and we got opportunity to put a relatively high rise partition, 12 meter high, and I'd like to show you short videos of this. It was like, if I may say, it was like a open air gigantic fire resistant test with this 300 ton of wood set in the warehouse, some aerated concrete block here, and a 6 meter, if I recollect correctly, times 12 meter of high gypsum board partition. As you will see later, single frame, no wall in the cavity. You can see that the fire has been gigantic, with level of temperature close by 1000 degrees sustained during 2 hours of time. I hope, Musba, the video was able to be seen by all the attendees.
Yes.
Yeah, okay, that's good. It's a bit extreme condition, but it was a unique kind of a unique occasion to set our system in a real case. On the exposed face, and it was kind of a surprise after this, the outer layer of gypsum board was still in place. As you can see, a bit of joint opening. It's hard to see, but a bit of cracks here and there, but the board have not fallen. Getting back to some of the installation details I gave you, I'm getting back on this. So it was, sorry, I said 12, it was only, if I may say, 11 meter high wall. It was back-to-back stud. So the back-to-back stud and 400 millimeter distance was here to ensure the structural stability. So you remember that the prerequisite of any good fire-rated system is make sure that structurally the system is well designed. You can see this in the USG board manuals, or you can talk with mechanical USG board mechanicals, or if needed with R&D folks. You see here the top rack has a pretty deep flange of 100 millimeter, and we did apply the rules of 5 millimeter per meter of partition of free gap, so that there was a 55 millimeter thermal expansions, which I believe is one of the points that explained that there was relatively few deflections and no fall of fireboards on on the exposed sides of this gigantic fire. Towards architects or developer, I was willing to finish this presentation of safety in building in case of fire by some I would say design of curved walls. Do we have any experience of fire rating on curved wall? The answer is yes, and that's one of the capability that we do have with gypsum boards, the regular board or fire boards. They can be installed with a curve radius. You see here a partition here, a bit of extreme partition with two curves that has been tested. We have two other smaller and narrower curve radius partitions. So they allow like versatility and design on the 3D design of curved designs, adding to the aesthetics and the design to the fire safety and the passive fire safety offered by the gypsum boards. I wish to thank the audience for listening to me to the end. I think Musbah, I got more or less 1 hour talk, or maybe 55 minutes. I don't know if it was far too much, but enough for the attendees to get a discovery or maybe a refresh on about fire safety, building codes, and revealing a little bit of the secret of gypsum board based system. Thank
First
you.
off, honestly, I felt it's as 5 minutes only. It was very smooth.
Okay.
Well, thank you very much. We are hosting for the first time. Hopefully, it wouldn't be the last. Hopefully, that we will see you more frequently on our technical webinars, Christophe, honestly. So
sure,
again,
there are some other R&D folks that will be, I'm sure, happy to speak. Either it is acoustical comfort or structural designs, or you know, fire safety in a specific segment. I'll be happy to support here, and I'm eager interacting or hearing about any question and answer, and hopefully I'll do my best to answer to any type of question. Thank you.
So thank you, Christophe, for presenting our 9th technical webinar. Again, for all attendees, the coming webinar, which will be the 10th, will be on the 28th of September 2021. The registration is now open on our online usgme.com website. Each participant will be receiving a 1-hour CPD certificate, and the recording of this presentation as well, it will be available on our online website. Going back to the questions, Christophe, let me start with the first question. In the fire resistance tests, slide number 11, which you mentioned the curve of 1 hour, 2 hour, the incremental curve of the fire. Would the fire curve vary between the American and European standards?
That's a good question. There's this was slide 11. You say, Musbah, right?
Yes.
Yes, maybe this one. Yes.
Yes, this one exactly.
Yeah. That's a good question. Actually, the Astm is not exactly following these equations, but it's close to. It's very close to in terms of fire dynamics. The difference between Astm and some other standard is more on the type of furnace thermocouple that are used to pilot the burners and the internal pressure that is existing within the furnace. So it's a little bit technical here and not touch on this testing methodology aspect. But if I would describe the Astm, over 1 hour, it tends to be at the start a little more higher than the ISO curve, then to be relatively equal at 1 hour, and to be slightly below. What drive me to tell it's almost same is that the differences between the Astm temperature time curve and these ISO 1, the ISO 834, these equations, is from memories, I recollect correctly, is in the plus minus 50 degree range all across this fire rating. So plus minus 50 is quite a gap. But when we consider the nominal level of temperature, let's say from 10 minutes, I like to say for it is considered it's relatively the same at the end in terms of heat and energy output out of 1 hour and equal out of 2 hours. But the dynamic would be slightly more quicker at the start and to be slightly starting to slow down at the end. But in terms of energy output, if we do consider the surface below this temperature time curve, Astm and ISO, I like to say would be same.
So since and it's almost same within 50 degree miles plus, would be there any differences in the testing, Christophe?
As for me, and this is a bit technical, something that goes in favors of the ASTM standard is usually the ASTM test. Is the case in the US, are driven with negative pressure in the furnace. What it means, negative pressure? It means that the pressure within the furnace is less than what it is outside. So it means that there is like fresh air or air from the outside getting into the furnace, whereas all the other, say like BS, ISO, KS, Korean, there is a positive pressure, but there's a gradient of pressure in the furnace, but there is most of the system that is exposed with positive pressure, slightly positive pressure, meaning that this is the hot air and gases of the furnace going through the systems. And this difference of pressure regime between ASTM and the others, in my view, technically speaking, is providing a little bit of advantage for ASTM, making that it might be a little bit easier to pass a fire ratings per ASTM than it is with other standard. Again, I'm speaking of very few time gap here.
Thank you, Christophe, for this comprehensive answer. Another question, following the American standard, what is the difference between the Type X and the Type C?
That's a good question. I see here that we are having some expert. Type X and Type C is calling for a type of formulation of recipe, and Type X. Let me get back to a plan. Type X is usually 5.8 or 15.9 millimeter board that is formulated with glass fiber, and I like to say glass fiber only. But it's 15.9, whereas usual portfolio Middle East is having UL and Type X and Type C boards, but we do have systems that can be based on half-inch or 12.5, 13 millimeter boards. Type X board is 15.9. It means a little bit thicker, a little bit denser. Remember, more combined water and with glass fiber, and it's a typical board used for vertical system, wall system. The Type C board would be relatively close to what is described as the pink fire boards. Is one board that is having a mix of fire additive. One is a glass fiber, same as Type X, but higher content than the Type X, and vermiculite. So a combination of two fire additive. And I'm not sure it's correct, but a good way to remember between Type X and Type C, usually the Type C board, like per UL, are more dedicated to the ceiling system, horizontal systems, where the gravity effect is calling for a better design or formulated product. So Type X, a little bit lighter than Type C and glass fiber only, if I may say. Type C, a little bit denser, combination of glass fiber and vermiculite, but both boards are relating to tens and tens of UL designs, providing a wide range of fire rating from half an hour up to 4 hours, either be walls, ceilings, or structural protections. We do have these Type X and Type C boards made in our Oman plant, and we do have also similar boards made in, of course, in the US and in USG Bowl Finland. I was in charge of transferring this recipe and the UL certification to Asia. Musbah, I hope it answered the question.
Yes, really, it's very comprehensive, very specific. For the suspended ceiling, if you allow to answer the question, which standard following to the test of fire suspended ceiling? Is it the ASTM E119 or the BS 1364?
Good question again. Both. And it depends here on your regulations or the building codes. ASTM, so the ASTM set of standards are quite popular in Middle East and are also accepted in few countries in Asia, such as Singapore. Most popular or still a popular system are the BS 476, but the EN 1364, I think, is the or BS EN 1364 would be the standard that is applied in Europe for the European market, but that is to cover and superseded the BS standard, and that is also more and more introduced in the building codes. But either ASTM in 119 or the EN are like two different type of standard, but leading to the relatively same testing methodology. When I say relatively, we have just shared that the ASTM temperature time curves and the EN1 relating to the ISO was differing a little bit. The type of furnace thermocouple was a bit different, and the pressure regime a bit different, but I think it's going a bit too far in the technique of this. For tonight is that get information from the local regulation and the building codes to assess which testing methodology and which type of standard applies. Depending on country, this can be one specific one, let's say ASTM only. On some other country, I like to say it almost doesn't matter. Either BS, either BSEN, either ASTM applied. So I think Musbah in the Middle East, it's mostly not only, but mostly ASTM that is quite popular.
In the Middle East, we have all of them. We have the BS, we have the EN, and you have the ASTM.
Okay, no, that's a learning. I thought that the ASTM had the preference of the most civil defense, but it's really true that Thomas Bell Wright Lab in Dubai, I'm thinking about this one, is accredited for various standards. And again, as an accredited lab, they can provide and run fire resistance tests for Middle East area or for anywhere in the world. So that was again a good
maybe John he
technical
can
questions.
or يعني هلا for the Thomas Bell Wright they are testing yes for this assemblies EN, BS and ASTM, but based on Middle East it's very crowded with the iconic projects, and it's from the source of the architect and the specifier the specs come. So we need to comply with the most rigorous specs within the region. Another very specific question, Christophe, and I'm happy with the quality of the level questions we have been asked so far.
Yeah, that's very good, very high.
Yeah. Is there any specific construction for the 2 hours fire-rated partitions that uses 2 layers of 12.5 fire-rated boards on each side? There is any specific construction similarly to the sealant, strips, parameter, the assembly of board, horizontal, vertical? Is there special construction details for the 2 hours fire-rated board?
Assembly? Yeah, it makes me think that I could add one slide on this. So we have seen that the double layer 12.5 or thicker boards on the steel frame is ensuring 2-hour fire rating, and this can be either per ASTM, EN or BS, because we do have a business unit testing according to this. I've shared on the expansion of metal frame, but to accommodate with the structural moves, it's key that at the perimeter of the systems, there is a gap. I like to say maybe a 10 millimeter, 1 centimeter gap that is fitted between the boards and the, let's say the concrete, either slabs or the concrete columns. these joint having to be filled with a fire or fire acoustical sealant. One, it will ensure the integrity and the thermal insulation at the perimeter of the system, although it's not per se a weak point of the system. But as I mentioned, leaving this gap and this flexible gap with a technical joint will ensure that with regard to the racking move or structural move of the building, when subjected to load or wind loads, there will not be any crack developments. So the sealant at the perimeter of the system, for the gap to leave at the perimeter of our systems, and the fill with fire or fire acoustical sealant is an important detail to get in mind. This is ensuring the passive fire safety of our system, as well as for acoustics, ensuring or decreasing or canceling what is called the flanking transmission effect. So to keep the fire safety and the acoustical comfort of our system.
So Christoph, what you are talking about, it's the testing is for the full assembly, not for the board itself or for a single part. So the testing
is correct. It's yeah, system test and in a I don't have maybe clear picture to illustrate this, but it's a good point because in the fire systems, in a full-scale system, let's say typically 3 meter by 3 meter walls, we do leave this 10 millimeter gap that we are filling with fire sealant.
Very precise answer. Thank you, Christoph. Another question for the false ceiling. Would you please provide more insight of the false ceiling in protecting various building structural systems? For instance, is fire resistance requirement different if the structural system is reinforced concrete versus or wooden? So if you use a plenum, a different structural side of if it's wood or steel or reinforced concrete, there will be any, what will be the role of the false ceiling protecting, or there will be any change on role of the assembly?
It's again it's an excellent question here. It depends on the type of structural load bearing of the floors. So this can be concrete beam, this could be steel. It depends if they are protected, if they need to be protected, and it also depends on what is being laid or not between, let's say, the concrete slab and the ceiling. If there's a free plenum with just steel hangers, nothing combustible within the plenum, that's okay, and we can, I like to say, almost go without any fire-rated ceilings. There is some ceiling or corrugated ceilings or unprotected steel load-bearing systems, which needs to be protected because protected to where the heats. And here, in this case of design, the fire rating of the ceilings will be to ensure and to delay the transmission of heat or fire to the steel structure. So typically, if we are having two load-bearing floor, one with reinforced concrete, which interestingly is providing easily 2 hours or more by itself fire protections. So without the need of any fire-rated ceiling, just like a regular one in the example of free plenums. If we do take this same load-bearing flooring, but it is supported by steel frame, here the ceilings need to provide adequate protections, and we might need a 2 hours fire ceilings protecting a steel frame loaded floor, whereas no ceilings or just a regular one ceilings would be used on reinforced concrete. It's a mix here of technicals and building code with regard to what are the fire rating and what are the solutions which the architects or developers are using.
Thank you, Christoph. Another question. You have explained very well for the installation of the fire-rated drywall assemblies. However, there was no more clarification on the drywall ceiling installation. Could you please just quickly elaborate more installation of a fire-rated drywall ceiling assemblies?
Yes, sure. As I mentioned, the mechanical design adequacy is a prerequisite. We are dealing with steel furring channel. The free gap at the end of the furring channel is also important. When exposed to it, this furring channel can extend. So between the steel corner, or this is the U corners, and the furring channel, there's need to be a free gap, similarly to the one we leave between the studs and the top rack. Getting back to the good remark and question about the free gap and the sealant at the perimeter, for a ceiling, similarly to partitions, it's key to leave all across the perimeter at the level of the exposed plasterboard, at least the plasterboards, 10 millimeter, at least 10 millimeter gap between the boards and the structural walls, let's say concrete, to be filled with sealant. This is here also to accommodate with the structural moves, or due to winds or air circulations. What else? In case, and this is often the case for fire-rated ceilings, where there is multiple layers of boards, just to stagger the joint, either the cross joint or the vertical joint of the boards in between layer. Kind of similar principles applied for the partitions that are also applied for the horizontal elements.
And just adding question, it's again just the full assembly of wall and ceiling. Should have the same fire rating assembly? 2 hours for ceiling and 1 hour for wall, or this doesn't matter? First off,
yeah, it would depends on how, if the wall is going to floor to slab, or if it's stopping at the level of the plenum. I'd like to say here to simplify and unify, thinking of building codes aiming at providing a fire resistance for a full volumes of a room to prevent the extension of a fire from room to room or from floor to floor, that it should be at least equal. Yeah, having a 4 hours wall with a 30-minute ceilings where there will be an open plenums would not ensure at a large scales a robust fire safety design.
Very close question to the ceiling installation. How, as an expert, you can maintain the fire rated for ceiling, since it has more parts, the lighting fixtures, HVAC, openings, it has more open.
Yeah.
So how you can maintain the full structural stability for the fire?
Yeah, no, that's also a good point, almost a tricky one. But with regard to the functionality of ceilings, one is to provide protections to the load-bearing structure we have seen, or to protect any combustible things. But it has also to accommodate with AC, M&E, lighting, and this. Two things for these systems, as a system only. They as like a penetration systems, they have to provide through intumescent agents a kind of fire protections. Obviously, they cannot provide 1 hour or 2 hours. And in the building codes, there is an acceptance, a limitation and acceptance of, I would say, of openings, telling that out of such a surface of ceilings, for such and such type of buildings and occupancy, we can accommodate up to 5 or 10% of openings. It means that out of like a 100 square meter ceilings in scattered area, either due to lighting, ventilations, air coolings, it's acceptable to get a limited amount of area that could be open or quickly be destroyed in case of exposed to heat. But it's a tiny relative amount of surface that is tolerated out of a large surface of ceilings. And in terms of penetrations, there are also solutions to to combine opening or pass-throughs of duct or cables or ventilation system while providing protection. This is here almost like a active fire protections. I'm thinking of Sika, Hilti, or Promat products, which can provide some sealant or intumescent belts where, when exposed to it, in the case of a plastic system fallings, it's swelling and blow up to a point of closing the aperture. Okay, it's lost. The equipment, either lighting or air cooling, is lost, but it can be fitted with some perimeter or back, let's say, sealant or intumescent sealant that can have an active protections when exposed to it. I like to say, Musbat, that this is the role of this equipment provider to get this tested, either be included in, like in traditional masonry, concrete wall, or gypsum board wall.
So eventually, it's the role of whom, Christoph, to maintain that the stability of the entire ceiling with the opening, it does not exceed or does not be more. It's responsibility of whom?
So one is a building. One is the building codes and being aligned with the role of the building codes. When I said this is the liability of the providers of this lighting or air cooling device, that whenever it has to be included in a fire resistant ceilings, this system must be combined to intumescent collar, paste, or joints, which will insure and close the aperture once this component, usually kind of organic or plastic based, will disappear. This is the role of this manufacturer, all the providers of this active fire protection system, Hilti, Sika, Promat, to ensure that these solutions, these pass-through solutions through walls or ceilings, are fitted and tested through various type of wall, either be concrete, either be gypsum boards.
Christoph, just a quick glance for the curved wall partition. Is it following the same testing criteria, and what would be the type of board used for the curved wall partitions?
Oh yeah, that's a good question. It's quickly to answer, this is the same type of system. You have seen the arrangement. It was made in one company furnace that is quite deep. You need to get space and enough depth of the furnace to install this, but the testing methodology is same. The type of board can be, it depends here on the curve radius. So very, very small curve radius, like below a meter, we need to deal with 6 to 9, 10 millimeter boards. But for larger, I saw two pictures. One first was kind of a large curves, 12.5 millimeter FR board can be used and can be curved. There is some trick on this. Either you wet with a sponge the back of the boards, or you put some linear cut, which allow you to screw and curve the boards. But the installation would be almost same as what happened on a straight and flat partitions, but with some specificity in the installations. So it's dependent on curve radius, but this could be done with a 12.5 fireboards, multi-layer fireboards.
Christoph, we see sometimes at the installer they do some cut on the backboard for doing
yes.
Does this will maintain the fire integrity, or this will be considered a violation?
Yeah, that's a good question. This will maintain. I'm saying this because I drove this experimental two tests with curved partitions. What happened with you create a mechanical cut just to curve. So yes, there is a cut, but considering that the curved partitions, you will close the gap. You have a curved systems which has a purely like core integrity density without any crack. The fact is that for curved partition, if ever you are faced to 1 hour or more fire rating, it's better to go with a multi-layer systems, not only a single curved partitions. You can go with it if you only have like a 30 minutes or no fire ratings, but for a 1 hour and 2 hour fire rating, it's good to consider multiple layer boards installation.
It's good to mention here, Christoph, that we have a special accessory, special tracks, specially produced for the curved wall. Yeah, we don't
Yes,
follow the
correct.
conventional track. We have a special here in the Middle East. We do a special fire-rated track with a curve, with incline, decline. So the entire assemblies are available to comply with.
Yeah, no, but architects are very imaginative and design, but I say we can combine high level of passive fire safety and a nice wall design, if I may say.
A question for a one layer type X 15.9 with stone wool insulation. Would it achieve the 1 hour fire rated?
Tricky question. I would like to ask, tell me more about your rock wool. Now, getting back on the type X and type C, it's not that it's forbidden and you cannot make it, but the type X is usually not to be used for sealing due to the gravity and the joint opening. But there is a but, and that's a good point to ensure fire safety and maybe also acoustical insulations. If above the frame you put thick and dense enough rock wool, and here in this example, I would think at minimum of 15 millimeter thick and 40 kilogram per cubic meter rock wools above the framing, then by itself, the thermal insulation on the integrity should be ensured. So at the condition that the rock wool is thick and dense enough, as I just described, my guess is that, yes, the Type X should do the job. But is this a single layer Type
Yes,
X?
it
Okay,
is
because let me tell a little more. Without any wool, for 1 hour sealing, we would need double layer 15.9 Type C. Here, if it's a single layer Type X, you really need to use good performing rock wool, which can be expensive. So my point would be maybe go with 2 layers of Type X, or better 2 layers of Type C, 5/8 inch Type C without any rock wool. The rock wool here is that you would need, he said one single layer for 1 hour. I'm afraid this will not be enough. But Type X, due to gravity effect and lack of anti-shrinkage, might fall as soon as before around 30 minutes, leaving part or all the ceiling frame being exposed to it, and meaning that this would be difficult to keep the rock wool flat and smooth for an extra 30 minutes. My point would be, I would feel much more safe, so first by using Type C, but the question was a Type X, to go with 2 layers of Type X and rock wool. From experience, if you go to a fire rating, because single laser Type X, unless using a thicker and denser rock wool, which I described, that's close to be impossible mission.
Christoph, we have a lot of questions. Up to you to decide whether if you need to continue, if it's okay, because I know it's now almost 9 p.m. at your time. So if you are okay, we can continue. If not, we can send them a question. So is it okay to continue with you for the questions?
Okay. Let's go up to 9 p.m. local. Then if I'm starting to starve, I will tell you, or maybe you might see me collapse. So then the webinar will be finished. But we can keep in touch, and you can send the question later. We can keep the flow in. No problem.
Very, very energetic, Christoph, as always. So let's continue for the questions. What would be the minimum thickness of metal frame for the fire test, partitions and ceiling? There is any minimal for this wall and ceiling, or both the same?
No, good question again. I've not gone into the detail, but through the some of the videos or the picture that I've seen, and I like to get back to the 11 meter high partition. The thickness of the stud was 0.5. It was BMT, so it might be 0.55 millimeter. Usually 0.5 millimeter or above is, structurally speaking, a minimum thickness. Then you need to consider the center to center distance between either stud or frame. But let's say for a quick and brief answer, 0.50 millimeter, I'm not sure what it is in inch, would be a minimum thickness, but that allow a very large. So it depends also on the sections, on the width of stud, and on the size of flange, but 0.50 millimeter for a steel-based frame.
Christoph, you have mentioned during the presentation that no need to fix the stud on the top of the track. But
Yes.
does the system will fail in the host stream test if it's
No.
not attached?
Yeah, that's a good question. I have some video of the Ostrom test, and I see there is good specialist of Astm tests, which I appreciate and admire. You know, with regard to the free expansion that we need to allow between the top rack and the stud, there's no mechanical fixing between the stud and the rack, but there is mechanical fixing of the board to the stud and the board to the rack. So in some way, there is a mechanical continuity of fixing between board and stud. What has to be avoided is a steel to steel connections, because if we do a stud to rack connections, then we will lose the free expansion. That's the first point. Second point, the Ostrom, just quickly, that's an Astm base. You have to run two tests. One, your desired fire rating, let's say 2 hours fire rating time. A second one, the Ostrom, where the similar system need to be exposed at 50% of its time, 1 hour, and then being subjected to relatively high pressure Ostrom application during 2 to 4 minutes. But the structure of the structural and mechanical adequacy will be maintained, and in this case, this would be maintained through the boards, either the exposed one or the non-exposed one, which is ensuring a continuity of mechanical fixing being fixed to the stud and the top rack. So no fixation between stud and rack, but fixation between board and stud and board and rack.
And this will maintain.
This will go well for the Ostroms. All the Ostrom tests I've seen, mostly in the US and one in UK, went through this, and it goes well.
And the host stream should be from one side, no penetration. Yeah, from one side will be, but the other side, no penetration.
Yes, the Ostrom is, yeah, that's a good point. Is the Ostrom is applied and is sprayed on the exposed side, and the criteria with application of several minutes that there's the Ostrom should not go through the partitions.
Yeah. About the corner fixation for the partition, it should be staggered edge or no issue. And what about the V-brace? Should it be a W or M? You know, here in the...
So let me see the question on the edge.
Yeah, this is in the private. We are receiving some question in the private and there's in the Q&A. So we're using the V-brace here in the 20 framing systems for the for the cinema. So on the edges, should be staggered edge or no issue for the corners. And for the V-brace, yeah, he's mentioned should it be a W or M? The installation of the V-brace to the two studs. Yes, exactly. I will show here. If you allow, I can just.
Yeah, I'm familiar with the. I mean, W or M. Anyone can see what they want, but this is here for preventing or decreasing the solid transmission for acoustics. So I think I can answer on the V-brace. This is the edge. Staggered. Staggered, do you mean box stud or staggered stud?
No, staggered the edge of the board. I will show the demonstration of demonstration of the V-brace. Just quick, I will bring from my desktop while you answer the second question. There will be any recommended gap between the board, any recommended gaps between both for the fire systems in order to pass the tests?
You mean, is the gap meant between the wall and the concrete? I mean, between our system and the structural design, or is this board to board?
Recommended gap between boards. Yes, board to board.
Okay, is board to board is no, like I like to say, is no gap. The taper edge and square edge has to be in contact, and for what is the outer layers, like usually treated with junk compounds. So no gap and kind of intimacy, if I would like to say, or contact between edge to edge, either be lengthwise edge or the crosswise one.
A nice question. We always been asked this question. Is the drywall naturally fire rated?
Yes, that's a good question, because from what I've explained on the formulation of gypsums, and with a content of around 20% of combined water, standard board or regular boards, single layer, offered a little bit of fire resistance. I think I mentioned in one example that okay, there is need of a minimum dry weight of the 12.5, but a 12.5 standard board, which weight would be at least 8 kilo per square meter, so no fire additive, 12.5 millimeter, 8 kilo or more. Each side of this would provide half an hour. It's not a lot, but it's a little bit something.
I have the document, but I don't know. I cannot share it.
Yes.
Present. Let me present. Okay. So this is the V-brace. Quick. This is the typical of. This is the 47 decibel and above.
Okay. It's a very high-end partition, acoustical and fire partition.
Yeah, it's acoustical. This is for the cinema, and this is the typical. This is the cut plan, and this is the section on top, and this is the cut.
Yes. Okay. Good.
The brace between
yes.
20 framing system here, and it's from the section wall. And here, presentably, the 3D view. So all of this
very nice design.
Yeah, all information are available with our technical team, and it's accessible. The good thing, Christoph, that we share these with our stakeholder as complimentary, free of charge services. So this is as accessible, and we can share on request such technical, and it's available, by the way, on Revit for BIM compatibility and CAD. This is an advancement which we offer as USG Middle East for our partners. So I hope that this is can answer the question. We have 7 minutes left for you, so we need to utilize them very quick. How we prevent mold mildew on gypsum board? This is something that has nothing to do with fire.
Yeah, no, that I can quickly answer. I mean, mold can grow on everything, including glass and aluminums, but we do have mold-resistant board, mold stop or mold block. We do need to put an active additive into the core, kind of a biocide family, very, very, very small, that allow to prevent and to provide the mold resistance. Just for information, there is Astm-based mold resistant standard, where the gypsum board is set in close to in foliums, and just to make sure that in a very wet and concentrated atmospheres of it's not bacteria, I forgot the name. There is no mold development during this, but there is it's a common board, but we need to put a specified additives into the core. By the way, I wish to tell that this can be combined if needed with fireboards, and this additive is very tiny. This can go in a mold board, could be combined with a mold moisture or mold fireboards, but we do need to put an active additive into the core.
In the event after of the fire, the unexposed room to the fire in the same building, is it required to be changed, to be replaced after the event of fire? That's
a good and difficult questions. I like to say it depends on the time of reaction of this. If ever there has been an event, there was 1 hour wall and 1 hour wall, and the fully developed fire within one single rooms, and ideally either the fire die by itself or the fire brigade reach on time to clean and to clean the systems. Obviously, the exposed wall will be to be replaced. The non-exposed one, depending on the thermal impact that there has been, could be kept in place or needing to be replaced.
Christoph, very quick, for the multi-layer system, drywall, is it required by norms to tape the first layers?
No, that's a good question.
Only the first one.
It's not required, and either be ceiling or either be partition. The approach or the guidance of USG Ball is just to apply your surface finishing and jointing on the outer layers only.
Any tolerance for the fasteners installation, or it should be as per book? Or the
yes, per book there is either in the plain board or in the edge of the boards, like let's say like 300 millimeter plain board or 200 or 150 in the edge, but this is per book, and the fire system design and the screw pattern is, by the way, similar between a non-fire rated or fire rated system. So this is per book. No need specifically to increase the density of screw.
No, not the density, the spacing between the screws.
When I say sorry, the linear density of screw, it's a R&D way to speak of number of screw per linear meter.
Okay. So this is, I was waiting for this question for the duct. Always you are receiving in the Middle East for the enclosure of ducts for the ceiling. Any consideration should be taken in during the design and installation for fire resistive assembly for the horizontal or vertical ducts assemblies?
Are we speaking here of steel duct or fire resistant duct, Musba?
No, it's fire resistant.
Sorry?
It's a fire resistance assembly.
Okay, because we do not have per se gypsum. We could have, but we could transfer, but I like to say we don't have gypsum boards that can be used to make fire resistance duct, either exhaust or ventilation duct. Is very specific product and very specific test. So if this is to protect the steel duct, it's kind of similar, a little bit similar to what I've presented for the column and beam encasement. Despite here, a duct is not a structural load-bearing component. It's self-load-bearing, but not load-bearing. But if you are speaking of intrinsically fire-resistant duct, we do have to consider mostly calcium silicate product, or like I don't want to name brand, but like a Promat-based duct, because it's very specific and niche market. We can protect steel duct, but we cannot do, we could do, but we could not do fire resistance with our paper-faced gypsum boards. This would need non-woven glass mat, thick and dense boards. When I say thick and dense, 20 millimeter or 25 millimeter. That could be done through technology transfer, but the niche market has not led us so far to consider this.
I have plenty of pending questions, Christoph, and I think that we are very close to close this webinar. So we will arrange a question and answer document,
yes,
including the entire questions and the coming one which we couldn't answer due to the time limitation. And we will make sure to publish this this document to on our online website after we collect all of questions. So people are free to send us questions onto the chat box or privately on our. I will mention our contact information here, and we will come into entire document having all these answers. So sorry for that we couldn't answer all of your questions, but I'm sure that we have covered more than 2/3 of the answer question. The density of the question, Christoph, explained how much the Middle East markets really it's educated in terms of when it comes to the fire assembly and the density, the number, and the specific questions. So I'm happy to receive such a question. I'm happy to host Christoph, in this.
I appreciated the engagement, and I have to say I'm a bit puzzled by the technicity and the high level of questions, CISB systems for testing methodology. I think we are dealing with already quite educated people. Maybe my training and webinar was useless, but the high level of question is satisfying to me. Very good. And if there is need of a specific shorter webinars or just a Q&A section, happy to do so if there are so many questions that we need to talk again.
I see that we should arrange another one in the coming quarter, Christoph, and maybe we can host you once the COVID restriction were reduced. Maybe we can host you here to have an one-to-one, face-to-face technical presentation.
Yeah.
Something in the Middle East. This is just to elaborate more and to fasten our relation as a manufacturer with regulator, with distributor, stakeholders. So just USG Middle East, we always try to maintain as the balance within the region for supplying drywall assemblies and sealing systems. So thank you, Chris, in particular, and thanks all of our kind attendees
thank you
for this constructive 2 hours technical summit. It's no longer webinar, and we'll keep in touch with all of you. And I will just before I will mention email address that for people who need to drop any further questions. Before I close the meeting, I will mention it here. Anyone can keep sending questions. I have just sent a message for everyone. Thank you, Christoph. Thanks all. Wonderful evening, everyone.
Yes. Thank you, everyone. Have a good end of day or a good night.
Thank you. Bye-bye.
Maybe a good lunch. Bye-bye. Bye-bye.